Hello, everyone. I'm Omar Hafiz, instructional designer in the educational services team of NetWitness. And let's go to our final topic, which is ESA best practices. So we'll start with the ESA guidelines, which include writing rules, deploying rules, and system health. I will talk about each one in details. Here in writing rules, the purpose of an alert should be to notify you of an event that requires immediate and specific action. For events that do not require action or only require you to be aware, you can create a report. Configure alert notifications only after your rule testing and tuning is complete. This can help you ensure you do not get flooded with notifications if a rule behaves differently than you expect. Rules need to be specific so that you limit resource usage. Use the following guidelines to limit usage. Make the filters on the rule exclude all but the necessary events for the rule to fire accurately. Make the size of your Windows time for correlation, as small as possible. Limit the events that you include in the window. For example, if you only want to see IDS events, ensure that you only include those events in your time window. Next, we'll be moving to deploying rules. If you deploy small batches, it's much easier to tell if a particular rule has an issue. ESA rules are not one size fits all. Not all rules will work in your environment. The rule descriptions tell you which parameters you will need to modify to successfully deploy a rule in your environment. Live rules have parameters that need to be modified. If you do not modify your parameters, the rule may not work, or it may exhaust your memory. And we'll be moving now to systems health. So a common issue is that new rules may cause memory issues. To prevent this, you can set up new rules as trial rules. Set up thresholds in the health and wellness module to alert you if memory usage is too high. There are metrics in the health and wellness module that track memory usage. You can set up alerts and notifications to send you an email if those thresholds are crossed. Also, just because an ESA rule is provided through live content does not mean it should be applied. Every rule should be based on a specific use case that has been defined by your company or organization. Rules need to be tuned to an alert level that is manageable. If you are flooded with alerts, then the purpose and utility of an alert is lost. It is also possible to flood the database, which is the MongoDB that stores alerts, which can slow or prevent your system from processing alerts. So for example, if you want to know about encrypted traffic to other countries, try limiting the list to countries. Now we'll be discussing ESA statement types in terms of performance. As you can see here, the first row explains the filtered stream. So if the rule is a select and only has AND or logic, and it is not partitioning or using any other type of view that requires caching data, it should not cause memory issue. Then we have our second point, which is a filtered stream with view. So here if the rule is a select and does have a partition by or some other view, then the rule has a potential for memory increase. This should be directly proportional to the number of unique values that match the partition. The rule should not affect CPU. This type of rule is a simple select with group by. Then we have the match recognize type. If a rule uses pattern matching with match recognize, it has a potential for both memory and CPU issue. These conditions are depending on the ordering of the ingested data and the number of triggered events. Moving on to the fourth row, which is the pattern type. If a rule uses a pattern with followed by or / greater than, this rule has a potential to have an adverse effect on ASPR. And finally, using a named window with a time constraint will have medium to high effect on memory and CPU. Now we'll be moving to writing for performance. So to avoid performance issues, we follow these guidelines. We include boundaries for statements such as time and counts, and alert without boundaries may continuously trigger, and use match recognize whenever possible for pattern-based event use cases due to lower memory usage. And avoid creating a large number of groups with a small or zero number of data points. A highly selective metadata field like event description could create a separate view for majority of events. And creating contexts within the statements should be avoided due to memory concerns. Instead, use partition by and group when to create separate views for data. And finally, instead of workloads, directly filter the event streams. So thank you all. And please don't hesitate to contact us on our email and LinkedIn page you guys find here. I hope to see you all in future sessions. Thank you again.